They are the strangest objects in the universe, dark, powerful, mysterious, warping space, bending time, and defying everything we thought we knew about reality. For decades, scientists have tried to understand them, but black holes still guard their deepest secrets. And what if I told you that the real story of black holes is even more incredible than we ever imagined? Today, we'll uncover 5 surprising truths about black holes. Revelations that might just change the way you see the universe itself. So sit back, relax, and grab a snack, because you're not just watching a video. You're stepping into the unknown. The journey begins now. Despite what their name suggests, black holes aren't actually holes at all. They're not empty spaces, and they're not portals to other worlds. At least, not in the way we once imagined. A black hole is made of matter, real physical matter, compressed into an incredibly small, incredibly dense point called a singularity. It's a place where mass has been squeezed so tightly, so powerfully, that the rules of physics as we know them simply break down. Picture this. Take a star several times bigger than our sun, then crush it down. Smaller than Manhattan, smaller than a single city. That's a black hole. A single teaspoon of black hole material would weigh billions of tons. Around this singularity is the event horizon, an invisible boundary where the pull of gravity becomes so strong that not even light can escape. Once anything, a planet, a star, even a beam of light, crosses that line, it's gone, trapped forever by the unstoppable force of gravity. Inside the event horizon, space and time themselves stretch and collapse. Every law of nature we understand, from gravity to time, starts to behave in ways we can barely imagine. Black holes don't just sit silently in space. Many of them spin, and they spin with unimaginable fury. When a massive star collapses, it holds onto its angular momentum, its spin, just like a figure skater pulling their arms inward to spin faster. As the star shrinks down into a singularity, its rotation accelerates, faster and faster, until some black holes spin at over 90% the speed of light. And when a black hole spins, it drags space and time along with it. This cosmic whirlpool effect is called frame dragging, where space itself is pulled and twisted around the black hole. Near the event horizon, time slows dramatically, space bends, and gravity behaves in ways that seem almost impossible. But spin does something even stranger. Around a spinning black hole, there's a region called the ergosphere, a place where space-time itself is being dragged faster than the speed of light. Inside the ergosphere, it's impossible to stand still. You're forced to move in the direction of the black hole's spin. And here's where it gets even more incredible. Scientists theorize that if you enter the ergosphere, you could perform something called the Penrose process, a way to actually steal energy from a black hole. By carefully dropping part of a spacecraft or object into the ergosphere and letting it fall into the black hole, the rest of the craft could escape with more energy than it entered with. In other words, spinning black holes might not just devour energy. They could give it back. In the distant future, advanced civilizations could even use this phenomenon to tap into black holes as the ultimate source of power. Black holes don't just warp space and time, they hold the potential to reshape entire civilizations, if we dare to get close enough. And this phenomenon isn't just happening in distant alien galaxies. At the very center of our own Milky Way lies a supermassive black hole known as Sagittarius A. Sagittarius A is about 4 million times the mass of our Sun, a silent giant hidden behind clouds of dust and gas. Today it's relatively quiet, gently pulling in small amounts of material. But scientists believe that millions of years ago, Sagittarius A was far more active. Evidence suggests that powerful jets of energy once erupted from our galaxy's center. Jets strong enough to light up the surrounding space, push vast clouds of gas outward, and ignite massive bursts of new star formation. These violent outbursts, triggered by our own black hole, may have shaped the very structure of the Milky Way itself. Entire waves of newborn stars may owe their existence to the ancient activity of Sagittarius A. When you look up at the stars on a clear night, you're not just seeing random points of light. You're witnessing the echoes of cosmic violence, the silent fingerprints of a black hole that helped sculpt the galaxy we call home. Without Sagittarius A, our night skies, and maybe even the delicate conditions that allow life to exist, might look very different. Black holes feel eternal, ancient, untouchable, and for most of cosmic history, they are. But even black holes, these titans of gravity, are not truly immortal. In the 1970s, physicist Stephen Hawking made a groundbreaking discovery. Black holes can slowly lose mass over time through a strange and subtle phenomenon known as Hawking radiation. At the very edge of a black hole, the event horizon, the laws of quantum mechanics come into play. Tiny pairs of particles constantly flicker into existence. One particle falls in, while the other escapes. From a distance, it looks as if the black hole is leaking energy, bleeding tiny amounts of mass back into the universe. Over trillions and even quadrillions of years, this slow process causes the black hole to gradually shrink. Eventually, it evaporates completely, releasing a final burst of energy and then disappearing forever. In the farthest future we can imagine, long after the stars have died, after galaxies have faded into cold darkness, black holes will be the last giant standing. But even they will one day vanish, leaving behind only silence and the faintest echoes of a once living universe. Today, black holes are one of the most studied and most mysterious objects in the universe. But for centuries, they existed only in theory, strange whispers in the mathematics of gravity. In 1783, an English clergyman and scientist named John Michell first proposed the idea of a dark star, an object so massive and so compact that not even light could escape its pull. At the time, it was pure speculation, a mathematical curiosity lost amid the birth of modern astronomy. For more than a century, the idea gathered dust. It was too strange, too extreme to fit the known laws of physics. It wasn't until the early 20th century, with Albert Einstein's theory of general relativity, that the groundwork was laid. Suddenly, gravity wasn't just a force. It was the warping of space and time itself. In 1916, a German physicist named Karl Schwarzschild, working under the unimaginable conditions of World War I, found the first mathematical solution describing what we now know as a black hole. But even then, the idea was seen as a theoretical oddity, a strange corner case of the universe, unlikely to exist in reality. For decades, black holes remained mostly the domain of science fiction, painted as cosmic monsters, gateways to other dimensions, and end-of-the-world machines. It wasn't until the 1960s and 70s when astronomers discovered powerful X-ray sources like Cygnus X1 that reality caught up with imagination. These strange objects behaved exactly as theory predicted: invisible, powerful, consuming, and utterly real. Today, black holes are no longer just myths or theories. We've photographed them. We've measured their gravitational waves rippling through space-time. Once a wild fantasy, black holes have become one of our greatest windows into the hidden workings of the universe. Proof that sometimes the strangest ideas imagined by dreamers and explorers turn out to be more real and far more extraordinary than anyone could have ever dreamed. This is Fact Inquisitor. Thank you for being a part of this journey, for daring to wonder, to question, and to explore the unknown. Stay curious. Keep reaching for the mysteries beyond the stars. And remember, don't just watch. Be part of the journey. Because curiosity isn't just what we do, it's who we are.